A plus B plus C. That is what we have seen yesterday. See, this is vector A, this is vector B, and the tail of vector A to tip of vector B we join, that is A plus B, and we have to add C with A plus B. A plus B we got this pink line, that is the A plus B, and we have to add vector C with that. So where its tail, vector C, that its tail is kept at the tip of A plus B. Tail of vector C is kept at the tip of vector A plus B. Then how will you find A plus B plus C? Where to where we have to draw the line, children? Where to where you have to draw? A plus B is that pink colored line, A plus B vector. Then C vector we kept. Tail of vector C is kept at tip of vector B. Then how will you find A plus B plus C? That is the question. Okay. A plus B plus C. How will you find? Bhagat, tell. How will you find A plus B plus C? Where to where you have to draw the line? Where to where, Bhagat?
Tail of
Ah,
tail
ah,
of A
vector A to
tip of
vector, tip of vector C.
tip of
Ah,
C.
C, very good. Tip of vector C. So I have drawn a line from tail of vector A to tip of vector C, blue colored line. That is this part, left side, A plus B already drawn, plus C. C, tail is kept at A plus B's tip. Then join tail to tip. Tail of vector A to tip of vector C, we have drawn the line, that is A plus B plus C. Next is we have to show that is same as A plus B plus C. So next part, same figure we are doing it. B plus C we have to draw, B plus C. So you just draw a line from, see, this is the tail of B and this is the tip of C. B plus C is obtained by drawing a line from tail of B to tip of C. This vector I have to draw from tail of B to tip of C. So B plus C is got, B plus C is got. And you have to add A, first is add, this is A, and B plus C we got. So when you join tail of A to tip of B plus C, we are getting the same vector, A plus B plus C. So that is proved here. A plus B plus C is equal to A plus B plus C. So you just draw in your note, children, and try to prove that. Okay, try to prove this. Next we have to study null vector. With different vectors, a unit vector, null vector, different types of vectors are the unit vector, null vector, those things we have to study. Okay. What is meant by null? Null means what, children? Null. Null means what? Anyone? Anyone know? Null. Krishna Priya, what is meant by null? Null. Do you know? Zero. Null vector. Yes. Null vector means zero vector. Okay. So what will be its magnitude? Zero vector. What is the magnitude of zero? Magnitude of zero. 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 Magnitude of zero is zero. So magnitude of null vector will be zero. But we are adding that vector symbol over it. Zero, right, and the vector symbol is put over it. That is representing zero vector. How will you get zero vector? When a vector is added with the minus of that vector. Do you know what is minus of the vector? That I will explain first. What is minus of vector? See, here I have drawn two vectors, vector A, vector B. Length of this vector or magnitude of this vector is, what is, can you see? 1, 2, 3, 4. 4 centimeter is the magnitude of vector A. and arrowhead shows the direction of vector A. Its another name is vector OP. Vector OP equal to vector A. Its magnitude is 4 centimeter. Direction is given by this arrowhead. This is this direction vector A is acting. And I have drawn another vector, vector B. It's also having 4 centimeter length. 1, 2, 3, 4, 4 centimeter length. I named it as vector QS. It's another vector, but its length is same. Direction also is same. So I can say these two vectors are equal. Vector A equal to vector B. So when I can say these two vectors are equal, children? When I can say these two vectors are equal? If they are, Parvati Umesh, when I can say these two vectors are equal? If they are, Parvati Umesh, tell. When can I say this vector A equal to B? Or why I am saying vector A equal to B? What is the reason? Not
They're in the same direction.
They are in the same direction. Only that is needed. Only
The
direction
magnitude
is
is same.
magnitude also is same. Then only we can say magnitude and direction both are same. Then only we can say these two vectors are equal. So that is the meaning of equal vector. Clear? And I will show another picture. You have to tell whether these are equal. This vector is having 4 centimeter, vector A dash. And vector B dash is having 4 centimeter itself, same length. But B vector's direction is slightly different. Not in the same, they are not parallel. And no arrow mark, you see, this is another direction. This direction is different from this direction. See, A dash direction and B dash direction are different. Are they equal? Can I say vector A dash equal to vector B dash? Can I say?
No.
No. Why? Their magnitude are equal, but what is different?
Directions. Not same.
Direction is different, not same. So we can write A dash is not equal to B dash. Okay. Negative vector, I will tell you. Negative vector. Okay. This is vector A. How much centimeter? 5 centimeter length is there. Arrow mark is given by this arrowhead. Arrow mark is shown, direction is shown with the arrowhead. OP, vector A is named as vector OP. Always, in order to represent a vector, you have to put the arrow mark over it. Textbook, you might not see this arrowhead because bold-face letter sometimes they use to represent the vector quantity, children. But when you write in notebook, you have to draw this vector symbol. You have to draw this vector symbol to represent a vector quantity. And here you see, this is same length. This vector is having same length, 5 centimeter, but its direction is opposite. Same length, but direction is opposite. So, can I write these two vectors are equal? Can I write? Children, are they equal? Are they equal? Sriram, are they equal?
But they are in different directions, right?
Okay. So we cannot say they are equal, but we can tell they are in opposite directions, equal to minus of this vector A. Vector A is minus. This is minus A vector. Vector A's direction is this. Minus A vector A will be opposite to this. So this is minus of vector A. So we cannot write vector A is equal to this vector. We can write equal to minus of this vector. Direction is opposite, but magnitude is same. Next, a multiplication of vector. See, multiplication of vector. Vector A, this is having 1, 2, 3, 3 centimeter length. Vector A is having 3 centimeter length. 1, 2, 3, 3 centimeter length. Vector OP, I used these letters to represent vector A. Vector OP, 3 centimeter length. Then twice vector A. twice vector A. How will you find twice this vector? This is 3 centimeter. So twice this vector will have, what is the length? What length it will have? Twice. This is 3 centimeter. Twice vector A. What is the length?
6 centimeters.
6 centimeter, correct. So you have to take a scale, draw a line with 6 centimeter, and you have to mark the direction so that these two are parallel, same direction it is showing. So twice the vector A will not change the direction, but it will change the magnitude only. Magnitude of twice vector A will be twice, 2 times of this vector, but direction will be same as that of this vector. Okay. Then here a minus vector is shown here. This is vector A. This is vector A. Its length is 2 centimeter, and minus vector A is drawn here. Minus vector A, opposite direction, 2 centimeter itself, but the direction is opposite. So you can tell this is twice vector A. This is vector A, this is minus vector A. And you are asked to draw a vector minus 1.5A. Minus 1.5A. This is 2 centimeter. So what it will be? Minus 1.5 times. This is 2 centimeter. So 1.5 times 2 means how much? 1.5 times 2 centimeter. What is its length now? 1.5, 3 centimeter. 1.5 into 2, it will be 3 centimeter. But this is minus vector A, and into 1.5 is done. So length become 3 centimeter, and direction negative vector A's direction. Negative vector A's direction. Negative 1.5 A. So this is meant by negative vector. So that is what we are explaining. Negative of a vector. So negative vector, that is when we study null vector, we should know what is a negative vector. Null vector. See, vector A is added with negative of that vector. For example, this is 5 in magnitude, and this is 5 itself. Magnitude is 5, but opposite direction. So when we add those two vectors, negative of vector is 5 plus 5 minus 5, what is the answer, children? Plus 5 minus 5. When they are added, plus 5, 0, just like that. So plus vector A and minus vector A, when we add them, we get 0 vector. Understand? 0 vector. For example, when a body starts from A and the displacement is 5 meter towards east, then he came back to the same place, and same distance displacement he covered to reach the same place, return. So for example, you go from your home to school and back to school, displacement becomes 0. So displacement vector is a 0 vector when you come back to your home. So that is the example for 0 vector. And another example, body is at rest. What is its velocity? Body is at rest. What is its velocity vector, children? Body is at rest. What is its velocity vector? Is it having velocity? Body is at rest. Is it having any velocity?
No.
No. So what is the velocity vector then? 0. Body at rest will be having 0 velocity. 0 velocity vector. Now that is example for null vector. Okay. Displacement also 0. When body is at rest, displacement is 0. That we represent by 0 vector. But velocity is vector quantity, we know. So when body is at rest, velocity is 0. 0 vector. Okay. So vector A minus of vector A will be 0 vector. That is, and we have to study the properties of vector. So what is the magnitude of null vector? Magnitude will be, tell, what's the magnitude of 0 vector? From the name itself you can tell. What's the magnitude? From the name itself you can tell. Magnitude of 0 vector is 0. And you cannot specify the direction. You cannot tell the direction. 0 vector, magnitude is not there. So, direction not specified. Direction is not specified, no particular direction. No direction you can tell. So, null vector is a 0 vector. It's having magnitude 0 and no specific direction. No direction. Okay. That is 0 vector. So, properties are there. Properties of 0 vector. Just like 0 when it is added. 5 plus 0, what is, children? 5 plus 0?
5.
5, just like that. Vector 0 vector is added with vector A, we are getting that vector itself. No change is happening to this when 0 vector is added. No change is happening to this vector, same vector we are getting. Then multiplied, when zero's property we are seeing here. When 5 is multiplied by 0, what it becomes? 5 is multiplied by 0, 0. Just like that. A number, this is a number 5, for example, lambda, we are taking a real number. It is multiplied with 0 vector, it becomes 0 itself. So, when 0 vector is added, that vector itself, 0 vector is multiplied, it becomes 0. Then 0 into vector A, that is 0 vector multiplication. 0 into vector A, that is 0 vector itself. Okay. Then next, this is an example I told now. This is XY plane. Body is moved from P to P dash. This is the position vector. I will show another figure. This figure. Next is, we have studied different types of vectors, 0 vector, null, that is also known as null vector, and the magnitude of 0 vector is 0, and there is no specific direction for 0 vector. All those things we have seen. Next we have to study position vector and displacement vector. I will explain position vector. See, X and Y axis are shown here. X axis and Y axis are shown here. And here, see, this is the body is moving in this plane. And this book is a plane. And I have drawn the two axes. O is the origin. And when this is the motion, black color, that curve, you know, black curve, that is representing the motion of a body. Body is moving in this plane. Arrow mark is shown. From here it is moving. See, this is the motion of the body. And here we have taken 2 points. First you consider this point P. And where is that point from the origin? From the origin, where is that point lying? So that gives the position vector. So you just draw a straight line from origin to this point. Draw a straight line. OP. That is the position vector. When body is at P, its position vector. How will you draw position vector? From origin, you draw a straight line to the point P. And it is denoted with vector R, small letter vector R. That is the position vector. Small letter vector R, position vector. Then body is moved to other point P dash. So at a time T, body is at P, its position vector is drawn from origin to the point P, a straight line is drawn and arrow mark is shown. So position vector gives us two things. Which are they? How far it is from the origin, this distance. How far it is from the origin. That gives, position vector gives us how far it is from the origin. And also gives in which direction that particle or body is lying. direction of the body also gives. Arrowhead shows the direction. So position vector R gives us two things: how far it is from the origin and direction. In which direction? With respect to the origin, where the body is lying. These two things the position vector tells us. And at a time it is at P, and body is in motion, I told you body is moving on this plane, and at another time T dash it is at P dash, another time T dash it is at P dash. So where is its position? To represent that, we have drawn another line. Straight line is drawn from O to P dash. That is its position vector. Now position vector is changed. Position is changed. So position vector also is changed. R dash. R dash is the position vector now. Now what is the displacement vector? Displacement P to P dash. Body moved from P to P dash. At a time T, body is at P. At a later time T dash, body is at P dash. And now what is the displacement vector? Displacement vector is drawn. A straight line is drawn from P to P dash. This orange colored line you can see, that is the displacement vector. P to P dash, a straight line is drawn. That is the displacement vector. And displacement vector tells us how much distance the body moved in a time interval T to T dash. In a time interval T to T dash, how much distance the body moved. That is P. We got it by joining the point P and P dash with a straight line. So straight line gives how far it is from P to P dash. Straight line gives the magnitude, and arrowhead shows the direction in which the body is moved. So this is the way to represent position vector and displacement vector when a body move in a plane. So I'll explain here. This is origin. O is the origin, and we have drawn the two axes, x-axis and y-axis, and a body is moving in this plane. That black curve represents the motion of the body, and arrow mark is showing the direction in which the body is moving. And we have marked first at a time T, body is at P, and its position vector is marked. How? By drawing a straight line from the origin to the point P. We have drawn a straight line from origin to the point P. That represents the position vector, vector R. Arrowhead is shown, the direction. So position vector tells us how far it is from the origin and in which direction it is moving, where it is lying. With respect to the origin, where is it? It tells us, position vector tells the two things. Then at a later time T dash, it is at P dash, and position vector is drawn, straight line from the origin to that point. That is the position vector R dash. And displacement vector is the straight line joining P to P dash. Body moved from P to P dash. So we have to draw a straight line from P to P dash, and that will give the magnitude of the displacement. This length of this line give the magnitude of the displacement, and the arrow mark shows the direction of displacement. Okay. So now we know what is position vector and displacement vector. So here it's explained here, magnitude of displacement is either less or equal to the path length of an object between 2 points. See here, when body move from Q to E, it can take different paths. Different paths are available. Q, F, E, it can go. Q, A, E, it can go. Q, B, E, like that also it can go. Different paths it can take. But that are path lengths only. But displacement means the shortest distance from this position Q to E. That is we got by drawing a straight line. Drawing the straight line Q to E, if we draw a straight line, that only will represent the displacement. So different paths you can take to reach from Q to E. Different path. So only one path, this path, only that straight path, that case only the displacement and distance are equal. Distance and displacement are equal only for this particular case, the straight line distance, shortest distance between Q and D. The magnitude of the displacement is either less or equal to the path length of the object between 2 points. Equal to magnitude of path length is either, it will be magnitude of displacement is either less or equal. This case it is equal. When body move along this path, distance and displacement are equal. All other cases, the distance is different. Distance is more than the displacement. Only this particular case, straight line, when the body moves along this straight line, the distance and displacement are equal. All other cases, distance is more than the displacement. That's given here. Magnitude of displacement is either less. Displacement is, all these cases, it is less. Only this case, the direct movement, it is equal. Magnitude of displacement is either less or equal to the path length of an object between the 2 points. Displacement vector is that vector which tells how much and in which direction object has changed its position. So that is what we have studied now. What we have studied, position vector and displacement vector. Position vector tells us what, children? Vaishnavi, position vector tells us what? Vaishnavi? Vaishnavi. Vaishnavi is not there? Okay, I will ask to another one. Deepa, position vector tells us what? Deepa,
Hello, teacher.
position vector tells us what all things? Position vector. Here I told you now.
Sir, can you
You can't hear? Show the figure again. Position vector, vector R, gives us what all things? Deepa? Mic problem?
teacher?
Huh. Can you hear?
Sir, time ano?
Position vector, vector R, gives us what all things? No. Chandana?
Yes,
Chandana.
teacher.
Position vector gives us what all things? Vector R, I am telling. Direction
Direction of the vector
and
and how far it is from the origin.
very good. How far it is from the origin, and also gives the direction. Arrowhead gives a direction. Okay.